Good morning, everyone. This video is for lesson 10-2. We're doing area of trapezoids and rhombi and kites today. So you need your tip chart from yesterday. And when you printed the 10-1 notes for last lesson, on that same file is the 10-2 notes. So you probably already have these from yesterday, but if not, go to yesterday's lesson and print out just the 10-2 page. All right, so that's what you need. You need the tip chart and you need the 10-2 page of notes. And all we need to do today for the tip chart is add what the base of a trapezoid is. And actually, its base is of a trapezoid. So in a trapezoid, or for a trapezoid, it looks like this. For a trapezoid, the bases are the parallel sides. So the parallel sides are the bases. So a trapezoid has two bases. So I'm going to draw a little, I didn't leave a lot of room here to draw a trapezoid, so I'm going to draw one right here. So in a trapezoid, there are two bases. This top one is, they call it base 1 or B1, and this bottom one, they call it base 2 or B2. So a trapezoid has two bases, and that is the only thing we needed to add to the tip chart for today. And now on to the notes. So there are two formulas. This is the formula for trapezoids. This is the formula for a rhombus and a kite. And it says here that B stands for base. There's two of them, so B1 is base 1, B2 is base 2, and D stands for diagonal. So this is 1/2 diagonal 1 times diagonal 2. All right, the first thing you do on any area problem, even the ones that we did last lesson on 10-1, you always write the formula first. So this is a trapezoid. It is not a kite, it is not a rhombus, that's a trapezoid. So you write down 1/2 times the bases added times the height. And that is 1/2. The bases are 5 and 8. So this 8 is that whole thing. If it was only part of it, they would draw like a little groupie symbol like that. So with no grouping symbol, that 8 represents that whole base. So 5 plus 8. And this is how tall the trapezoid is. Remember, base and height are perpendicular, so that right angle gives it away that that's the height. And you have 1/2 times 13 times 7. And since these are odd and we're halving it, it's going to come out ugly. 1/2 times 13 times 7. You get 45.5 or 45.5. So 45.5 or 45.5 centimeters squared. That does not seem right. Hold on. 13 times 7. Yeah, 13 times 7 is 91. Never mind. It's good. It just seemed funny. Okay. Number 2. This is also a trapezoid. See, here's how you know it's a trapezoid. It's got two parallel sides, and these sides are not parallel. If these sides were also parallel, it would be a parallelogram, but they're not, so this is a trapezoid. So area equals 1/2 bases added times the height, 1/2. Okay. The reason you need to write down the formula first is because that's what tells you, the formula tells you what to look for in the picture. So base 1 is 6, and then they want base 2. Well, I've got a problem. I don't have base 2. So that means I'm going to have to do some kind of work here to find base 2. So here's one thing that you can do with trapezoids. See this base right there, 6? You can grab that base right there and you can drop it straight down, and that's how long this is. But that's not the whole base. That's just part of it. So now I need to do the work to find this part of the base. All right, so I don't know that. But what I've got here is a right triangle, and it has one side missing. So I can call that A or X or whatever variable you want. And I can use A, B, and C to go A squared plus B squared equals C squared. And that's going to give me that missing A value. A squared plus 4 squared equals 5 squared. A squared plus 16 equals 25. Subtract 16. A squared is going to give you 9, and then square root. A is 3. So see, I know that value. That value is 3. That's how long this part is. So now I've got a whole base. And the whole base is the 6 and the 3, which makes a 9. And then the height of the trapezoid is this line right here. So remember, a height and a base meet each other at a right angle. So that's the height. And so you get half of 15 times 4. And then you can just punch that in a calculator exactly the way it looks. So half times 15 times 4. You get 30. This is 30. 30 feet squared. Now, some of you may notice that half of 4 is 2, so we're really just multiplying 2 by 15. So you can do that a little quicker and not have to use a calculator if you notice things like that. So this would be like a 7th grade level trapezoid problem. This is a 10th grade level trapezoid problem. So you did some area when you were younger, and you did problems like this where they give you all the right parts in all the right places. And then this is the same topic, but they've amped up the math required to find these missing values that go in the formula. See, area is one of those topics that can be taught at all different levels. Okay, rhombus. You've probably never used this formula before. I don't think it's taught in the earlier grades for area. So 1/2 diagonal 1 times diagonal 2. These are diagonals, this and this. Okay, so I need diagonal 1. It doesn't matter which one you call diagonal 1 and which one you call diagonal 2. So I'm going to call this one diagonal 1. In all parallelograms, including the rhombi, the diagonals bisect each other. They cut each other in half. So this diagonal is cut in half, which means this half equals this half. So that diagonal 1 is 6. So remember, diagonal 1 means the entire diagonal. And then the same thing is happening with diagonal 2. In a parallelogram, diagonals bisect each other. So this whole diagonal is cut in half into a 4 and a 4. So that whole diagonal is 8. And then you just multiply 1/2 times 6 times 8. You can do that in a calculator, and if you want to, that would be 24. 24, they did not put units on here, right? They just said that this was 3 and this was 4. So you just put units squared. We don't know what it's measured in, so we just call that units. All right, next one is kite. At any time during these lesson videos, if you want to pause the video and then try the problem by yourself and then press play again, that is a good idea just to see if you have it. So this is a kite, same formula as a rhombus. 1/2 times diagonal 1 times diagonal 2. 1/2. Okay, let's call this short one diagonal 1. In a kite, that diagonal's cut in half, but that one's not. So this diagonal's cut in half, which makes that a 3, and that makes this a 3. So the whole diagonal is 6. And then diagonal 2, this entire length right here, well, they gave that to us over here. That's the same height as this. So that is 10. They had to give us that, because see, we don't know how this is split. Like if they had given us that this was 2, well, in a kite, this one's not cut in half. So they had to give us what that whole value was. So half of 6 is 3, and 3 times 10 is 30. 30 inches squared. So yeah, we don't know how that 10 is divided. And we don't need to know. We just need to know that whole diagonal. All right, number 5, last one. It's trapezoid. And so we write down the formula. 1/2 times bases added times height. See, you have to write the formula. You just have to, because that's what tells you what to look for in this drawing. Base 1 was given. That's a 5. Base 2, the bottom base, this was not given, so I can't put anything there yet. And the height was not given. It's there, but it's blank. So I can't put a number there yet. This is what a formula does for us, though. It tells us what should I be looking for. I should be looking for base 2. So I'm looking for this. Since I know this one is 5, I can do what I did up here where I pulled that 6 and I just dropped it down right there. You can take that 5 and you can just pull that straight down. And that is going to move to right here. But that's still not the whole base. That's just from here to here. So now I need to know this part of the base. And when you pulled that 5 down, that kind of separated off this right triangle right here. And since that's a 90 and that's a 45, this is a 45, 45, 90 triangle. And we learned last chapter that in 45, 45, 90 triangles, these two legs are A, and this hypotenuse is A radical 2. We learned that in chapter 8. So if A radical 2 is 10 radical 2, then this A must equal this 10. So A must be 10. That's what these are. That's 10, that's 10. And we just found both values that we needed to find base 2 and to find the height. So base 2 is now 10 plus 5 plus 3, which is 18. And the height is this value, same as that value. It's 10. And now we calculate this. I forgot to mention at the very beginning, when you have a problem like this, you always do what's inside parentheses before you do the multiplying. So like up here, I added the 5 and the 8 and got 13 before I multiplied everything. So 5 and 18 is 23 and 10. So you do half times 23 times 10. 1/2 times 23 times 10. You get 115. So 115. Again, they didn't give me units, so I put units squared. So some of the problems are pretty straightforward. They give you the values that you need to plug in. And then some of the problems are upper level area questions where you have to do either Pythagorean theorem or a special right triangle. There could even be some that you would have to use trig. If this angle was something besides 45, like a 42 degrees, then I would have to use trig instead of a 45, 45, 90. So it is possible that you'll have problems where trig is used to find missing values. All right, so that's all there is to trapezoids and rhombi and kites. So that is the end of lesson 10-2. Y'all have a great day, guys. And here is a look at Oliver, just for fun. Oliver, he is very unfriendly. Ollie. All right, I tried. Bye, y'all.